Have you ever seen your parents or other people testing the water in your fish tank or your swimming pool?
Have you ever wondered why they do that? Ever wonder why sometimes when it rains, statues start to look like this?
You've probably also heard of stomach acid, or if you've ever been sick, felt that burn on the way up. Have you ever wondered why there's acid in our stomachs?
All of these things, believe it or not, are related to one scientific concept that involves two letters, pH.
Hi, welcome to pH 101. I'm Miss Mistretta.
I'm Miss March.
And today we're going to learn a little bit about pH.
What is pH? Let's check it out. pH stands for potential hydrogen because it's the measurement of hydrogen ions in a solution.
Hold up, what's an ion?
That's so funny you ask. Let's take a look at these two atoms on the screen. On the left we have a neutral hydrogen, and on the right we have a positive ion hydrogen. Wait, what's the difference between these two? Let's take a look. Neutral hydrogen has one proton and one electron. If you calculate the charge, that turns out to be 0, so it's neutral. But if you look at the positive ion, it has one proton, so it has a charge of +1. So a hydrogen ion is a hydrogen with a charge of +1. That's why it's written as H+. That little plus is a 1. Another ion you're going to see a lot that has to do with pH is hydroxide ions. Hydroxide ions are a little different because it's an oxygen and a hydrogen bonded together that has a charge. Let's take a look at it and figure out the charge. Oxygen has 8 protons, but if it bonds with hydrogen and gets an electron from it, then it has 9 electrons. So we have +8 and then -9, and that overall charge turns out to be -1. So hydroxide ions are often written as OH negative because that negative is a -1.
Let's take a look at your screen for a moment. You may notice that the three things on your screen have one major thing in common. Battery acid, vomit, and soda all have a ton of red dots. If you take note of the top right corner of the screen, you'll notice that the red dots represent hydrogen ions. The fact that all three of these have a ton of red dots tells me that they are full of hydrogen ions. They're all solutions that have mostly hydrogen ions in them. This makes them acids. In contrast, these three solutions are bases. You may notice that they have mostly blue dots, which represent hydroxide ions. As you can see on the top left of your screen, the blue dots are hydroxide ions. So these are called bases, whereas our last slide had mostly red dots, and they were acids.
So how are acids and bases related to pH? Well, scientists have something called a pH scale, which is a series of numbers that run from 0 all the way to 14. Any number from 0 to 6 means that a solution is an acid. Any number from 8 to 14 means that solution is a base. And anything smack right in the middle, 7, is neutral. So what happens when the pH number decreases, when we go from 14 down to 0? Take a look at the scale, see if you can figure it out. So as the number decreases, there are more hydrogen ions, so it becomes a stronger acid. Battery acid is much stronger than a banana because it has a lower pH, more hydrogen ions. What happens when the pH number increases? Take a second to think about it. When the number increases, there's more hydroxide ions in the solution, so it becomes a stronger base. Bleach is a much stronger base than eggs, so bleach has a number 13, eggs is a number 8. Now, something that scientists are able to use in the lab that can actually tell them the pH of any solution is a common household item, cabbage juice. Smells terrible, but makes nice, pretty colors. Cabbage juice is an indicator because it changes color to determine the amount of hydrogen ions in a solution. So if we take a look at these pretty colors, they actually have meaning behind them. If the cabbage juice turns a darkish red, that means that your solution has a pH of about 1. When it starts to become more of a pink, it's getting closer and closer to 7, When it starts to become a purplish blue, then it's neutral, it's at 7. And then it starts to turn bluish green as you become more basic, or as the solution becomes more basic. And then cabbage juice will only tell you up to a pH of 12. So anything with that greenish yellow color is a pH of 12. So by using the cabbage juice, you can add it to any solution, and it will tell you the pH of that solution, and then you can use a number to figure out if it's an acid or a base. Lucky you, we're going to get to use this in class, and you're going to get to see all of these pretty colors, which is the point of this video. So by you watching this, now we have more time in class to experiment. Thanks for tuning in. See you tomorrow in class.